Hi folks, today we're going to be going over the back side of your unit cover and we're going to be going over the tens. We spent a lot of time going over the back of that cover, going through each of the boxes, understanding things like concentrated dilute, the definitions of acids, what are strong acids, what are our weak acids, what do the molarities, how they play into concentrated or dilute. How do you identify a base? What's the definition of a base? You're going to really need to spend some time and go through and understand what's going on there. Come in for help if you need it, but throughout this unit we use the back of that cover quite a bit, and that is kind of your go-to place for information. Spend some time on these slides, take a look at them, see if you understand what they mean. So again, we spent quite a bit of time going over that back of the cover. So really spend some time there so you understand what things are about as we go through all this unit. So now we're going to go to the tens. If you use that cover, you should be able to answer this first question. You're on a Science Olympiad team. You're given a bottle of base, a bottle of acid, and a bottle of phenolphthalein. Which two would you use to make a pink color? Well, you would use this phenolphthalein. That is an indicator of base when it turns pink, and I would have base. So when hydroxide ion comes in contact with phenolphthalein, we get a pink color. So when those two come in contact with each other, the whole thing turns pink. And that is on the cover of your unit pack. Suppose you had 4 bottles of base, and these are the molarities, and you had 4 bottles of acid, and these are the molarities. Your teachers placed 40 drops of phenolphthalein in each bottle of acid. Okay? So if I put phenolphthalein in an acid, nothing happens. It stays colorless. So suppose you randomly grabbed 2 bottles, and you mix them in a cell well. You have 3 reasons why the mixture of the 2 drops of each result in a colorless solution. Well, I could be adding a base and a base, and if I do that, there's no phenolphthalein there, and therefore it won't turn pink. I could be adding an acid and an acid. In this case, there's phenolphthalein, but phenolphthalein does nothing in an acid. To get a pink color, you need hydroxide ions, and you need the phenolphthalein. So you need those 2. So if you have an acid and acid, you don't have any hydroxide ions, and therefore it doesn't turn pink. The last one would be if your base, and this is C, and I'm running out of room down here, if my base was a low concentration. So let's say my base is 0.1 molar, and my acid was 0.2 or 0.3 or 0.4 molar. When I put equal drops there, the acid, which gives up hydrogen ions, will react immediately with the hydroxide ions and turn them to water. And at the end, all of these hydroxide ions get consumed because we have a higher concentration of the acid, and therefore there would be no hydroxide ions to react with the phenolphthalein. So those are our possibilities. If you had 2 drops from bottle Z and 2 drops from bottle X, the solution remains colorless. So 2 drops and 2 drops, you have a colorless solution. You had 1 more drop from bottle X, and the solution turns pink. X is what? An acid or a base? Well, if I add Z and I add X and nothing happens, but then I add some more of this X and all of a sudden it turns pink, X must be the base. I've added more base to it and therefore it turns pink. Which is more concentrated? Well, it took 3 drops of X and only 2 drops of Y to go pink. So X is less concentrated than Z, which is an acid. Took more drops of X than Z, so X is more dilute than Z. Write the net ionic equation for the neutralization of an acid and a base. This is kind of our generic for an acid, AQ. And this is kind of our generic symbolization for a base, AQ. And when the two go together, they make water. So we put these items into a beaker, and the hydrogens find the OHs, and they link up, and they make water. And this happens and happens and happens until all the pairings have occurred. And if there's one leftover hydroxide ion and there's phenolphthalein in there, it turns pink. If there's phenolphthalein in there and there's one leftover hydrogen ion, it'll be colorless. But this is the neutralization reaction, and we use that a lot. We'll talk about that a lot in this unit. When you add drops of acid to a container that has base in it, the amount of base does what? Pause the video, try to answer these next 2 questions. If I'm adding acid, that's hydrogen ion, to a container that's got base in it, hydroxide ion, these two will react together to give me water. So what happens to the amount of base? Well, these get gobbled up by the hydrogen ions, so the amount of base decreases. When you add drops of base, that's hydroxide ion, to a container that has acid in it, what happens to the amount of acid? Well, when I add these two together, they turn into water. So if I'm adding base, it's reacting with the hydrogen ions and turning to water, so my amount of base ends up going down because it's reacting with those hydroxide ions. The rest of the 10s are your homework. A lot of the answers come off of the cover. So make sure you have that cover handy as you are working.